Okay, so why innovate in diabetes and other chronic disease? Why are users driving innovation, and why has it taken off so much in the digital era? Or why are people innovating? They're creating solutions that don't otherwise exist, or don't exist in the form that users want them in. So Dana's explanation around wanting to create an alarm that would actually wake her up from a deep sleep was, the driving factor. There was an alarm, it wasn't sufficient, and industry wasn't interested in solving that problem. Cost effectiveness. A continuous glucose monitor is really expensive, but through innovating, you can make the cost of them much, much lower. I recently conducted an interview with the mother of a child with type 1 diabetes who'd taken part in a study using one of the NFC to Bluetooth converters, so to turn that little glucose monitor, called a flash glucose monitor using NFC technology, into a transmitting CGM. At the end of the study, she decided that she couldn't go without, or her daughter couldn't go without, continuous glucose monitoring, and is now self-funding a full continuous glucose monitor. The cost of using it on label in New Zealand is somewhere around $10,000 to $12,000 a year. You replace the sensor every week, and the sensors are $530 for 4, and you replace the transmitter every 3 months, and the transmitter costs $750. So you're looking at $3,000 a year in transmitters, and 52 divided by 4, so that 13 boxes of sensors at $530. So it was at about $9,000 a year or something in the end. So it's a huge amount of money. She described it as paying a second mortgage, and said that her husband was going to delay retiring by 2 years, so work to 67 instead of 65, in order to be able to pay for their daughter's CGM. If you go the DIY route, you can use the same CGM system for a fraction of the cost. The transmitters stop working because the batteries run out, and the batteries are just a very, very simple cell battery. There's 2 of them, and if you grind the plastic resin cover off the transmitter, you can pop out the batteries and put in new ones, and then put epoxy resin over the top. I do this as part of my work for a not-for-profit diabetes organisation, activist organisation, and the cost of the batteries is about $10 for 2. So instead of spending $3,000 a year on transmitters, you can spend about $40 a year on transmitters. And the sensors themselves, the bit that sits under your skin, if you replace them, you don't actually have to replace them every 7 days. If you go and use a third-party CGM app instead of the CGM app designed by the company that make the whole product, you can keep using the sensor for as long as you're getting good data from it. Basically, you get an electrochemical reaction that is triggered by glucose levels that creates an electrical current in the sensor wire, and the transmitter transmits what that current is and changes in that current to the app, and the app then processes that to work out what your blood glucose levels are. So I regularly get 28 to 38 days per sensor. So if you think at $530 a box for 4, if I'm getting, say, 28 days per sensor instead of 7 days per sensor, I'm cutting my costs again by 75%. So there are ways of doing it and making it much more cost effective. And of course, the study that I was just talking about, where we were testing one of those converter kits, the monitor that doesn't transmit, that just collects data and you read it with near-field communication, is, again, it's about $50 a week to use. So much, much cheaper, $2,500 a year as opposed to $9,000 a year. So cost effectiveness is driving innovation. Why else do we innovate? Because companies are very slow to innovate in the diabetes space and in health in general. it takes a long time to get stuff ready for regulators, and it takes a lot of capital. And so patients, users, can often innovate faster than companies can. And they can be focused on the needs of the communities. So many diabetes technologies have been driven with the FDA, so with regulators and health insurance companies in mind. This is in the States where most research is done in this field. In contrast, user innovation can be done quickly, cheaply, and it can iterate rapidly. So software development, digital development is all about get something going, and then once it's working, get it out, and then build the next version, and then build the next version, and build the next version. We can do that in the DIY space, in the user space, really effectively. Once you're looking at a regulated company, the regulators aren't equipped currently in the healthcare space. The major regulators are the EU and the FDA. They're not equipped to deal with this iterative process. They want to have one application, and they're basically set up that you get your application, you get your approval, come back with your new product in 4 or 5 years' time, and we'll deal with you again. So users who aren't going through the regulatory process because they're not producing a product for sale can actually sometimes move much more quickly and cheaply. And finally, as I've said before, users have always innovated in diabetes care. It's the reality of living with diabetes. But digital technologies allow innovation to be shared and scaled in ways that were previously unachievable. You can combine experts, people with potential expertise who never would have met before. You can share code efficiently and effectively. Of course, you can write code efficiently and effectively. But it's the social media spaces as well as the technical spaces that have been opened up in the digital era that are really important. So as Dana said, she regularly is on Twitter and meeting people of relevance. She got the initial code from John Kostick by reaching out through a tweet. Similarly bumped into Ben West through similar chance occurrences, primarily driven through digital social media. So why innovate? It's really important.